All right, today I'm thinking I'll go for 4 hours probably of streaming. I'm going to be working on arc movements still. I got most of it done yesterday, but I need to essentially refactor the code now that I've figured out how to do everything. So now that it's all basically set up, I need to tweak a few things, organize it a bit better, and then rework some things. After that, I'm going to be working on rotations. Rotations are pretty much done for the functionality, but I need to turn them into events so that they can be stored in the replay system. I'll show in the beginning here how the replay is working at the moment. Basically, the movements are working just fine with the replay system. Also, one thing I want to do is try to have the movement for an arc be calculated in steps rather than frame by frame. That way we can have targets along individual points on the arc rather than essentially moving along the arc per frame. And my logic for that is just to optimize calculations for objects that don't need to be as accurate as moving on the arc frame by frame. I think that'll probably be the last thing I work on, because it's something I want to tackle once I've got everything figured out for how it'll function, but that's something I want to look into. But anyways, I'm going to start working on the arc movement. I'm going to show a little bit in the beginning here and then work on rotations. Then if I finish working on rotations and the movement, I don't know what'll work on after that, but that should probably take me up 4 hours doing both of those. Okay, I'm going on mute now. Timestamps will be in the description if you're watching this at a later date. I think I'm going to talk on this a little bit just because I'm hanging on it because I'm not sure I quite understand it. Like, obviously, I know how to do the math of it, and I came up with it. I actually came up with how to do this yesterday. I didn't look up anything. I was just messing around with the circles and then realized that the distance between this and this is exactly equal to so I knew my center was here to get the arc I wanted, and then I realized that the lengths of this and this were equal. So from that, I knew I had a 90-degree angle here. I knew that I could calculate this length here. I could calculate this length here. What I needed to find was this whole angle. So essentially, what I'm trying to understand is how this is -1 to 1. And at first I was thinking it was the bisector angle, like we were calculating, like as if we were calculating this here. But then I realized we're not calculating the length of that, because this is always going to be just this distance here. So obviously that's not what we're calculating. What we're calculating is we're calculating the ratio of this. I believe we're calculating the ratio of this length to this here. Well, so the direct magnitude, well, I guess that's why I'm confused, because I wasn't remembering that the magnitude and the bisector are literally the same length. So like these two things are equivalent. So the thing that's getting me confused is the fact that these are equal. So I wasn't sure which one is actually being used, but in reality, they're essentially both being used, because what I'm doing is I'm really using this magnitude, and I should think of it and write it in the comments as such, because it doesn't really make sense to be using this, because then if we were actually using this, we would essentially be splitting it here and then drawing like that, which, I mean, you technically still could get it, but then you're like doing this here, figuring out, and then, well, not figuring this out, but then you're doing half the length here, which is half the radius. And so what we're doing is we're essentially splitting this in half, just using this length here. This is that 0.5 times direct magnitude. Then we're dividing by the radius, which is going to be this length here. And that is going to give us a ratio of how long is this compared to the entire radius. So the reason that's important is because it helps us find this angle here, because really it's finding us this angle here. But let's say, for example, these points A and B, well, not A and B, I guess. Let's say A and C here. So A to C, if it's there, it's a bit more difficult to comprehend like how this all works. But let's say instead we had something like this where it was here, but then also still here. Like point A is here and point C is here. Like point C is just right in the same spot. Well, okay, well, what's our length here? 0. That's pretty easy. So we've got 0 over our radius, which from here to here, well, I guess this length as well. So like, what's this radius? It doesn't really matter what it is. It could be 1, it could be infinity. Regardless, 0 over 1, we get 0. So what's the angle between this? Like, this is an easier example because you can clearly see the angle 0. That's why I think it's important to sort of simplify things like this. You can clearly see that the angle here is 0. Like, no one needs to know trigonometry to understand there's no degrees between A and C. So what we can do then is use that to prove how this all works and do the arcsine of this. Well, we don't have the angle yet. We know it will be 0, but we do the arcsine of that ratio, which is 0. And then that gives us the answer we're looking for. If I double check and do actual arcsine of 0, which will be 0 radians. So just simplifying it like this, you can see how the concept actually works. We're essentially getting the angle, finding the ratio of our of half the distance between them to get this bisected angle. So now let's do like something like, what if C was on the opposite side of the circle? So it's all the way over here. And so we can say C is all the way out there. Well, now we can clearly see that we split the circle in half. Like, this angle is obviously 180. That's pretty clear. So what's the distance from A to B? Well, now it's the entire length of the circle. And so again, you don't need to know trig to understand this angle is 180 degrees. And then you can easily, more easily understand the concept here that our length between A and C is double the radius. So remember that we're multiplying it by 0.5 though, because we're not using the entire distance between them, we're using half that. So we're using this here. And this half of this, we can clearly see it's from here to here. This is from here to the end there. So they're both going to be the same. And then this bisecting right here, same length as well. So that's going to give us 1 over 1. Well, it doesn't really matter what it is. It could be 5 over 5. Whatever the radius of this circle is, it doesn't matter because we're dividing by the radius. So in this example, you can see it's going to be 1. So even though you might not understand, like, what's the arcsine of 1? Like, I don't know that off the top of my head, even though there was a time I did, but long since forgot it. I know that this angle is going to be 180 degrees, and so I can intuit that this is going to be pi because that's 180 degrees radian. And so we get pi if we were to plug that into arcsine, and that's the length of this whole thing here. Now, simplifying that can show why the bounds of this are 0 to 1. It's actually -1, just if it was going in the opposite direction. But if we go all the way back and do this again and go to here, this point, back up here, and then down to A, now it's a bit easier to understand the concept of how this ends up working out and why you're able to do this and get the angle between them, because we're finding the ratio of this to this, and if it's half of it, well, then it has to be half the circle. So if we're at a half, then the arcsine of that is going to be 90 degrees. So doing stuff like this and working through it in a more working at it from the most obvious answers, I think is the best way to sort of figure these things out, because now you may not know how to calculate arcsine of 1/2. I don't know how to calculate arcsine of 1/2. Like I couldn't take out a piece of paper and tell you how exactly I would do that. But I know just from the fact that we did these other ones that it's going to be 90 degrees, because if arcsine of 1 was 180 and arcsine of 0 was 0, then if we're going in the middle of that, then there's got to be half that. It'd be funny if I'm wrong. So let's see real quick. Let me double check. Okay, I'm wrong. So, well, that's why you don't assume things, I guess. So I take back what I said. Turns out going from the simplest approach leads you to the wrong answer, because this would not be it's not a linear 0 to 1. 0 to 1. Because yeah, that'll give us 30 degrees. So it'd actually probably be square root of 2 over 2. Yeah, okay. I was being a bit stupid there. Essentially, it's not going to be the midpoint, because if we have 0.5 here, it's actually going along an arc like this. So if you think of our number line being in an arc where we're not going 0 to 0.5, but instead we're going the distance in a perfect arc from here. So instead of 0.5 being here, it's the length will be like 0.25 here. And then this is our 90. I think I'm messing all of this up. If 0 were the start, I don't know. Okay, I tried to explain this and then realized I had it wrong. But I think if we roll back to me not talking about half being 90 degrees, you can start to see how this concept works out in more difficult situations, like parts where we would need a calculator, because obviously I can't intuit what the length is here, as shown by me thinking 1/2 would be 90 degrees. So we could take this, take these two, and then you could even do like this. So that is about half. So we could even like make a rough estimation and say this is 30 degrees. Well, about that for arc cosine of 1/2. So anyways, all of this was to say that that's the calculation going on here. We're taking half that direct magnitude. So get the length of half the distance between origin and target as a ratio of the radius, which originates from, you can just say as a ratio of the radius. The bisector, the so the length will always be less than the radius, and it will only be equal to the radius when the 2 points overlap, or when the 2 points are complementary across the circle. Well, actually, it wouldn't equal the radius, then it would be just 0. Okay, so that's what's going on there. Then we do clamp it to -1 to 1. The reason we do this is because when you're working with floats, there can be miscalculations where essentially you get an answer that's like -1.00001 or 1.0001. And what we're doing here is just one line to clamp that dot. Essentially what we're checking is the absolute value, so the distance of the number from 0, is that greater than 1? So like, are we going over 1? If it is going over 1, then do dot divided by the absolute value of dot. So essentially, this works to clamp it, specifically because we're working with -1 to 1. So if you divide a number by a number, you're always going to get 1. And if we do the absolute value, we'll keep the sign intact. So if this is -1, well, if this is -1.5, it'll be, although it should never be going over that much. If it's -1.001, it'll be -1 because it's keeping the sign, and then the same with the opposite side of the spectrum. And this is only if it's greater than 1, so it's not like it's going to get 0.5 divided by 0.5 and get back 1. So if it's not greater than, then just do dot equals dot. Then we do getting the angle. So we do the angle 2 times the arc sign of the dot. And I wasn't multiplying by 2, was I? So maybe I was right. Hold on. That is my dog snoring if you hear that. Okay, so we've logged this, return that out, and I've finished commenting all of the math calculations. That's pretty much what I'm doing right now. I'm just trying to clean everything up, get it ready for future use. So if I ever have to look back at this stuff, I should be able to easily understand it. And I think I've gotten to that point. It's also set up to be used in any situation. So this isn't stuff just used for movement. I mean, obviously that's where it's most, like, that's its biggest use case is movement, but there will be situations where I want to do stuff with vectors. So this is essentially all just vector math. And most of it already uses Unity's built-in vector stuff. It just does a bit more things like potentially normalizing stuff, adding a relative position, and drawing the vectors. Yeah, and I think what I want to do is when I get these time estimations, I know exactly where we're going. So what I want to do is draw out sort of in a prediction of the movement, draw it out just to like visualize the arc outside of the subject of the movement. And I think the way to do that will be doing a while loop where it happens instantaneously, because we can't do a coroutine since this is a static method. Well, we could, but we would have to pass in some amount of behavior script that could then call coroutine, because these can't call coroutines, but we could pass in something that does. But that's too much work for just a visualization. That yeah, so I think we can draw it out. That way we get an idea visually what the movement should be looking like. Yeah, so I'm going to do that, start working on that. I'm realizing here, at least I'm pretty sure, I did this to get my center offset, thinking it was I figured out yesterday I could do this to get a different angle for our arc, essentially an orientation for our arc rather than the angle of the tangent. But I'm seeing here, I could use the same exact method to get this orientation because it looks to be exactly identical. Well, obviously not exactly, but identical to exactly the tangent formula. I don't know why I'm stuck on the word exactly, but it's got essentially the thing I need to pay attention to is which vector is the cosine and which vector is the sine. We've got perpendicular as the sine and down as the cosine. Now, the way I ought to do it is that direction 1 is the first is cosine, because that's like x, so xy, cosine, sine. So it should be that this is the first direction 1 and this is direction 2, but I need to go here and double check that. I was thinking ahead and doing it that way. Yeah, okay, I did. Cosine is the first one, sine is the second one. So what we can do here is then, also let's call this A. Okay, so what we can do here is pass that in. And instead of doing this, what we can do is literally just use that function, and we should get the same thing. We're going to want perpendicular for the y and down for a. So we can do equals utility. And this is the goal of making these methods static and on like a specific utility script. It's so that it can obfuscate this sort of stuff into very easy to read method calls. And then inside those methods, we can have organized, well-documented code that can be called upon again. So like if I'm always doing random stuff like this, I might constantly be switching up the way I do it. Like for example, here it's sine and then cosine, when really it should be cosine and sine. But when I was writing this, I wasn't thinking about that. But if I'm always approaching it with these static methods, then I know the consistency there. And if I ever forget this in the future, like I could absolutely see in the future, I come back to this code and I see like it's absolutely true without a doubt that I would come back to this code in a couple months or a week, and I look at this and I go, what the hell is happening here? Like I understand the math going on, but I wouldn't understand the concepts behind it just from reading this. But when I have it wrapped into a method, not only is it more readable, but it also tells me exactly what's happening there. Like, okay, we're getting a tangent direction between, I still don't quite understand what the perpendicular vectors and down is, but I understand we're getting a tangent direction to get the offset of our center. So there's just a little bit more understanding by having it in this too. So it's just all around better to try to wrap things, especially calculations, into static methods that can be customized and used all over the place, essentially as abstracted as possible. But so what we're going to do here is, like also with this, I have all this commenting, so like I can't mess up, well, it's harder to mess up certain things I could have messed up like this. Like for example, maybe I didn't have degree to radian here, or this was rad to degrees and this was degree to radian, sort of stuff like that. So what we can do here is do orientation. And then do false because it's an angle, not, well, it's an angle in degrees. Obviously it's an angle, but it's in degrees. And then direction. So some axis of orientation, that's going to be our perpendicular. And then vector 3 dot down. And, well, sorry, actually, this one first, then there. So now we have that. We can comment this. Okay, so now we've got that there. And now I'm just going to go through and fix all these. All right, I had to pull up my repository of code, which a good reminder for anyone working on code to do some sort of saving like GitHub, where you can save states of your code. Because I pushed yesterday once I got all the code working, because I wanted a reference point for if I ever went and changed stuff, that I knew I had a spot where things were good. And I'm glad I did, because when I started this, I remember thinking for a brief moment that I'm going to have issues because these are still vectors, but I'm changing what they are. But I completely forgot. And then I was trying to troubleshoot the issue just now. And I realized the problem was that this used to be origin to target. So essentially we were creating a direction from two positions, and now we have two directions coming in, because what we're doing now, instead of calculating a direction and doing perpendicular with up, like we are just defaulting to doing a cross with up, like how we're getting a cross between A and B. It used to be origin target gets us direction A, and then direction B is vector up. Like that's what it was. So what we actually need to be changing here is we need to have it be get tangent direction. For the tangents, perpendicular should be fine, but it's for the tangents. What we need to do is instead have perpendicular vector minus down. Oh, it's because this one shouldn't be changed, right? Yeah, because this one was actually correct, because essentially when I looked at this, I was thinking of the way I have it set up now, which is like this. So it's a good thing I ended up doing that, switching it to two directions rather than one specified direction and then one assumed direction of vector up. That's not exactly adaptable if we're having one be fixed to a certain direction, no matter what it is. And now we have, now we can like replace this. Although of course, the getting stuck on it is just me being forgetful. And eventually we'll figure this out. I don't know if we're getting closer or further away. I think the problem is with the center offset, which doesn't make sense because we have it back to what it was. So if this is wrong, then it's got to be that the perpendicular is wrong, because the perpendicular is what's informing what this does. So if this is the same, this has got to be wrong. So let's look. It was between get a perpendicular direction 0, right? And what was perpendicular? An origin and target. Yep. Okay. Yeah. So this one, it was the same thing where essentially what we should be doing here. Actually, I should have known this bad way to do it, because, well, I should have known this was wrong. How could I have a direction of 0? I think I even saw that and was like, how could I have a direction of 0? And then just didn't think twice about it. So that should be vector 3 dot right, and then we have this as up. So now it's instead of being a position, start and end position. So this would actually be, I might as well fix this commented code in case I ever uncomment it, because it's not going to work. We're going to need target direction. Okay. Now I'll cross my fingers and hope that's it figured out. Not quite. We're getting arcs sometimes. So the center's got to be in the wrong spot. Okay. So we know this is, well, we don't know, but this should be good now. Perpendicular. Should be drawing it. Let's see. Okay. So this is the same, so it's got to be good. This is the same, so it's got to be good. So how is the center? Let's do. Well, okay, I'm already doing this right. Let's, instead of drawing that, just draw center. So let's draw where the center is. So let's do that, and then also do center. Okay. know the first one is just a linear, so let's get that out of the way. Okay. So it's getting that. So our tangent is facing upwards when it shouldn't be. Okay, so we draw the center before that. So center offset's red, up is going to be blue. So we have our center on the ground, and then perpendicular going out that way. That's good. So these are right, and then the tangent gets messed up. So let's see. Tangent direction. Okay. Oh. Would that be it? No, we're not even using it here, so. Wait a minute. The black, white, and grays are perpendicular, if I remember correctly. Perpendicular will draw. Yeah, black, white, and gray. Okay. So yeah, perpendicular is going fine. But then the tangent is going off that way. So let's see, was it normalizing it before? That's what it is. Right? Oh, nope. What it is that the tangent didn't work like the perpendicular. The tangent worked as I had it set up already. So where the tangent is direction AB, it was already direction AB. Well, direction 1, 2. So actually, let's do that. So that's the issue there. That's why we're getting weird. That explains why it's going up. Yep. Okay. That's the problem. I should have changed those things as soon as I changed the method so that it would have been fresh in my mind, but oh well. This will hopefully. There we go. Okay. That's fixed. Back to normal. It's really cool that this lets me like essentially test like a whole bunch of different scenarios with movement and be like, okay, does it look exactly the same as it used to? Like I have it recorded as well, so I can see what it was meant to look like, and this is like exactly the same. I want to watch it slower. So I'd like this to draw where it's at, but I don't know how to do. Well, I know how to do that, but I don't want to give the information essentially for no reason. So we're drawing that out there. Which one's cyan? Let's see. I also want to take all of the draws out of the movement and just do it in math. Let's get this back here. Okay. I believe this is the time, right? Yeah. Okay. So that's drawing the time. It's not doing this, but well, it is and it isn't. Okay, so I think these are from within the method though. So let's see. There's really no way to draw it from within here unless I pass in the relative position, which I don't really want to do. Because I'm thinking it doesn't even make sense to get the relative position. Because if it's a direction, why would we get relative? I think what I want to do is make it so that's just for drawing. So what we can do is get rid of this one. I guess thinking whether I should keep the other version. Might as well leave it here. Let's just call it, make it obvious what it is. Draw. Can't mistake that this is for drawing. Okay. Do the same thing for perpendicular. Oh, and I can also switch this one back. Because this should work. This wasn't the issue, I believe, anyways. The issue was me switching this one. And then let's pass in. Let's also change. Okay, that should be good. I think there's just something about seeing the calculations happen so fast that's just mesmerizing. Like seeing it all drawn out too. Just like going back and forth. I think I have to unmaximize this to run it. Yeah. Just like seeing it go that fast. Pretty cool. And then obviously just the innate I don't know, catharsis of seeing arcs and circles perfectly drawn and all that. All right, I think I'm gonna end things there. Everything's working for the movement as I want to. Unfortunately, I couldn't get it to work with trying to fix the arc to be a bit more concise in the code, a bit more organized, but I couldn't get it to work. So I'm just gonna leave it as it is now. I've got everything done with the movement. It seems to be working well, and it's still working with the player. Like it didn't mess up anything the player's doing. So I think I'm going to leave it as is. It's something I can come back to later, and I certainly want to do more with it, but it's gotten to the point of where I wanted it to be at, so I should really just leave it and move on. And next thing to do is get rotation into an event. You can see there I was kind of showing the replay, and it's actually, I'm pretty impressed with how it's working in that it's basically already capturing like a fight. I mean, obviously the AI is not set up, but it's tracking every call. You can see like the player moving along in the same position and the mulking moving along in the same positions. So we're getting to the point where we could replay a fight, and it would do everything. The only thing it's not there is rotations, which is the next thing I'm going to set up, and then we have everything for the replay system for all functionality we'll need. After that, it's a matter of building the AI, improving the player character's movement, and then adding functionality to the actions. So we've got the actions, they just don't do anything. Like swinging doesn't cause damage for either of them. So the three big main tasks from here on out are rotation events, AI, better player control, and then just assigning like functions to actions, which I want to do modular actions for that, but I might just hard code all the actions to get something working, and then I can go back and figure out how to make that modular. I think that's a better approach. But then I'm also not sure how I'll design AI with that fact. So maybe this next update is just going to be player control, and then I can spend all of April cracking down on the AI, taking time to make all actions modular. So yeah, let's look at it this way. I can do just kind of spaghetti code for the actions of the players. Well, the functions of the player's actions. So like the actions are already modular and all that, with the animation setup where it's automated and it automatically says like, okay, just attach functionality. So the actual functionality that gets attached is going to be spaghetti for the player, and I will do that until I get a nice player controller. Have that be the testing for the end of this month, and then April I can spend all of my time getting the AI to work, and that should be good for end of April, because end of April will be trying to apply for the Steam Next Fest, which will be in July, if I'm predicting it right. It's not actually announced yet. And applications will probably be late April. So I'm thinking if I get the player control done this month, the next few days, then I can spend my time doing the modular actions, doing the AI, and that should be everything I need for like a good demo. Because I've got everything we need for the actual animations and all that. Just need functionality and then AI intelligence to actually be a challenge to the player. So yeah, that's the plan going forward, and I think I will end it there. Okay, today my goal is to be working on taking a brief break from coding to work on adding leaves to this tree. My friend modeled the base tree with some branches, and I'm working on just adding leaves to it. I can hide the leaves real quick. Okay. So my friend made the tree with the branches, and then I'm adding leaves to it and trying to get that to look good. The goal is just to have very simple leaves, nothing too complex. Although if I can't get it to look good with simple stuff, I might do something a bit more complicated, but the goal right now is just something simple. So I'm doing that, and then I'm going to texture it a bit and then get on to coding. For coding, my goal is to add rotation events. Currently, that's the only thing not in the event system for the replay functionality. The replay is the ability to essentially capture any sort of action in the game in the most general sense so that we can replay it. So like, let's say you fight a boss, and then once it's over, I can replay that. So that's like the practical use in terms of in-game, but it also has use, well, I guess that would be the mechanical use. It also has practical use for testing and debugging, where I'm allowed to essentially, I say essentially a lot. I'm able to show what I've done through inputs. That's good for testing because essentially, yeah, that's it. I can test certain edge cases by replaying them over and over again, and then I can go through the code, start debugging stuff, looking through the debugs I already have, see exactly what's going wrong, and keep replicating that edge case, which makes it very nice for, let's say someone's testing it, they can send me their replay, and I can literally go through each event. I could set it up where it pauses every time the event finishes, so that's a practical use for the events, but I need rotations. That's the only thing it's missing right now is rotations. Everything else is there. But yeah, just going to be working on the tree and then coding after that. So I'll go on mute now. I don't have too much to comment. Basically, just trying to get this to look good with the leaves, like adding leaves to it, and then also getting this in a texture atlas as well. So right now I've got the trunk in the texture atlas and these in the texture atlas. For the branches, I'm thinking I will just scale them down to be exactly one. Like unwrap here, but then just reset so they're all square, and then now I can make them all the same thing, because the branches, you're never really going to see them, so there's no point in texturing each individual branch when I can just do something like this where I make it one color just by painting this in, and then we can have them all just be one color. I think that's a big advantage to do something stylized. If this wasn't stylized and realistic, like if it was realistic over stylized, then I would have to texture these branches no matter what, because it would just be so jarring to see them as one color. Whereas in a stylized game, it's like, okay, that's one color, that makes sense. Like, you're going for minimalism here. You're not trying to make this look like a real tree. So stylized, aside from just personally preferring something stylized over realistic, there are so many just like constraints you don't have to deal with when you're doing something stylized. But anyways, that's what I'm working on. I'm going to go on mute for now while I work on it, and then maybe come back on. If you're watching this in the future, I mean like after it's live, there'll be timestamps for when I end up talking again, so you don't have to watch through all of the silence. And maybe I'll even end up doing like a full cut. But if it's the raw footage, I'll have timestamps. I think I might just comment on some stuff briefly to explain what I'm doing here, because I think it's kind of interesting what I'm doing with the art. It's not exactly the most intuitive way you'd be doing this stuff, or the regular way you'd be doing this sort of stuff. It's a bit more optimized, and I don't know the right word for it, but it's definitely a different way of approaching this sort of stuff. So I think I'll talk about it. So right now I'm just combining all of this so I can texture it as one thing. Basically, if I were to texture each one of these, I would have to switch between the objects to texture them. Like I'd have to go from selecting them to texture and then switch back to grab another one. But if I just join them all, since these have the same material on them and the UVs aren't changing, when I paint on these, it'll paint on the other objects. So I can just isolate these and paint on it. So I actually messed up here. I'm doing the RGBA masculine. This is essentially our default. That's just like a source I have. What I want to be using is this. And this is like a reference one. That's why it's just red, green, blue right there. We want to be using this, and we want to open and use our texture atlas. And the point of using a texture atlas is essentially, I say essentially a lot, in Unity, or really any game engine, when a asset's loaded into the scene, so let's go to Unity real quick. When the Mole King is loaded into the game, you have to load in his textures as well, which is materials, and then like the images, if there are any images. So this is using a traditional texturing technique where you render onto an image, and we're loading that in. And it takes processing power to load that image into the game. And specifically into the game scene where like you're seeing everything. So if you think of any modern game where you have a whole bunch of stuff existing in your scene, but it's not like everything that exists in that game. It's not all 60 gigabytes of that game. Like let's say you're playing Elden Ring or something. Like the game isn't going to load in every single image that it might need, or else that your computer would crash because it just can't handle that. You essentially have 60 gigabytes of data sitting on your hard drive that is ready to be pulled when it's needed. And the hard drive is the slowest. Even if you have an SSD, it's slower than RAM or GPU or CPU in terms of transferring data, in most cases anyways. So since it has the most capacity, but it's the slowest, then you only want stuff to be there that you don't need at this moment. So the moment the game realizes it needs that information, it pulls it out of the hard drive, puts it on the RAM, and then the RAM is where it's actually used in your game. So that's called a draw call when it pulls an image specifically. So when your computer pulls from the hard drive into the RAM and then processes on the GPU a texture, an image texture like the Mole King's body, which is all just one image, that's called a draw call because it's calling it to be drawn on the screen. Now, that's happening for every single image that has to be in the scene. So the ground is a different image, the hands are a different image, the mask is a different image, the player character is a different image. This texture over here is a different image. So it's drawing multiple calls. And you can actually see that, I believe it's in here, draw calls. If we do play, I think it'll show draw calls. Maybe not, but no, it doesn't look like. I'm sure I could add more settings here and be able to see it, but the point is you want to minimize the amount of draw calls. And the way you can do that is having a texture atlas where multiple objects use one image. And I can explain that real quick here with a different file. I'm probably wasting too much time explaining this, but I think it's interesting. So I'll take the time. Like this for these rocks. So there are 16 different rocks here. But since these ones share the same material. Well, all of them share the same shading process. So they're all shaded in the same way. And I can use these, well, they all get textured in the same way. So I can use the same image to texture them. So basically, there are 16 items here in one image for these 16 different objects. So let's say we have a scene where, and to be clear, you only want to do this when you know the objects are going to be existing in the same scene. Because let's say the game has 16 chapters, where each chapter is a scene by itself that does not require any other asset from any of the other chapters. So let's say each one of these was a different chapter of the game. Well, now, even though we're only using one per chapter, meaning we don't need any of the other resources, we're loading this entire image with every single object from each chapter. So that would be a case where your texture atlas is actually being a downside instead of being an optimization. So you can't just throw this at everything and say, okay, texture atlas, good. I'm going to use it whenever I want to because then we're doing less draw calls. It only works if the objects are existing in the scene at the same time. So I think the best way to categorize it is sort of that chapter mentality. But my game isn't going to be a chapter game. It's going to be open world. And so what I do is I define by region. So these are all going to exist in the canyon area of the game. So I'm calling them canyon rocks. Pretty straightforward there. And then I have it broken down from canyon to rocks. Like the other one's flora, so it'll be any sort of plant. We'll go into that one. Now, since we know these are all going to be loaded in the same scene, by loading just this image, instead of doing 16 different draw calls, if these were all their own images, like if this was an image like this, we're doing one call. So instead of doing 16, we're doing one. So that's how much we're saving time and processing power. Instead of pulling an image from the hard drive, throwing it into the RAM, processing it by the GPU, bringing it back to the RAM, showing it on your screen, we do that once instead of 16 times. And you can imagine for every single object that exists in your scene, that's going to optimize your game a lot if you're doing this to the best of your ability. Something to keep in mind, though, is the ratio of this. I'm not sure if you know about the power of 2 rules, but basically it's less relevant today, modern times, than it was when computers were first starting off, but it's still true that images in the ratio of the power of 2 are processed faster than any other ratio. So what I mean is, if it can be divided by 2, well, if it's a multiple of 2, not necessarily divided by 2. So 2, 4, 8, 16, 32. So like 2 to the power, 2 to the n. If it is one of those, then the computer can process it faster. I don't exactly know why that's true, but I know that it's true. So you want this ratio to be, first of all, square, and this is 512 by 512, which falls in that rule of 2 to the n. Now, it's not really necessary, like I said, in modern times, but it seems as hardware gets better, software gets worse because people tend to get lazy and lazy. Games are one of the last software fields where this sort of optimization, these little small optimizations, are still important. That's why you can sometimes see indie games that tank your computer and then AAA games that run perfectly. I mean, it's not always true. There are AAA games that perform very badly, and there are indie games that perform wonderfully. But if there's ever a discrepancy between the graphics you're seeing and the processing it's taking on your computer, like relative to all the competition out there, it's almost certainly because they're not taking optimization seriously. So this is just one thing. Like, this game's going to be pretty minimal, so this sort of optimization really isn't necessary, but it's something that is important to me to try to make these games as optimized as possible, because I never want it to be the case that someone can't play my game because they don't have the hardware for it. So anyways, that's a long tangent to say keep it in the powers of 2. And then you also don't want to go too large with this. This works because of the way I'm processing the shader. Like, this is, you'll see this is pixelated, but the actual image is pixelless. Like, there's no pixels to this stream, even though that's obviously pixelated. That has to do with the way I'm processing the shader. So that's a little cheat I'm doing. But the takeaway is, don't ever do this if it's too large. Like, let's say it was 6,000 by 6,000. That's like pushing it, because That's a very large image to pull, and unless you absolutely know that each one of these objects is going to be used in your scene at the same time, it's a big risk to be doing that, because that's a lot to push onto the RAM. Because RAM is typically like maybe 8 gigabytes, maybe 16 gigabytes. Like a lot of people consider 32 to be an extreme end of RAM for like just a casual user to have. So you have to be precise with how much you're putting on the RAM. And remember, things that are used in your scene are what goes on the RAM. Everything else will be on your hard drive and pulled when it's needed. So if we have a massive image here, like 10,000 by 10,000, that's just too much. It's just too much for the computer to handle. You need to not do a texture atlas, or do one a quarter of the size. Well, I guess a square root of the size. And yeah, so you don't want to go too large with it. You don't want to use it if the objects won't be used in the same scene. You want to use it when you have small objects, well, small image textures. They're going to be used in the scene, and they're going to be used in the same scene. And that's like the best scenario for it. And then try to keep it in the powers of 2, where it's a square image, and the square root of it is a solid number. I think that should be correct. Like if you had some sort of check for it, it would be, is the square root of this number an integer, or does it have decimals? If it has decimals, then it doesn't fit the power of 2. That's like the least of your concern when you're doing this stuff, though. Like the bigger concern is, how large is your image file, and are these objects used in the same scene? Those are the priority. The power of 2 thing is like, I really can't emphasize enough how much it doesn't really matter for modern computers. It's just sort of like a me being extreme about it, I guess. But okay, that's a very long explanation for how all of this technically works, and the reason for why I'm doing it this way. Now I'm just going to get into painting it. Basically, I'm going to paint onto these objects, and then try to get something that looks good. Then after that, I'm going to be working on the procedural system to get the leaves procedurally generated on the branches. Then once I've done that, I'm going to try to optimize the poly count, because the poly count is going to be pretty high. And I'm okay with high poly counts when it comes to static objects, because basically an object in a game has to be rendered to the screen, obviously. But an object that can move, such as like the Mole King or the player, it's every single frame, it has to be calculated where this is at, because it could be somewhere else. So if it could be somewhere else, then we need to know where it is, and so we have to calculate where is this object currently. But if we have something like this cube that's never going to move, and it's static, you can see at the top right, check static. It's never going to move, so we only need to know its position once. So if this had like 10,000 polygons, that's a bit high for what I'd want, but let's say it's that many. It doesn't really matter in terms of performance, because of the fact that it's not being checked every frame. It gets checked once, and then that's it. So that's when poly counts matters, when I know an object's going to be moving, and this tree is going to have some sway to it, and then it can also be broken, so it's not going to be a static object. So I need to try a lower poly count. Once I've done that, I'm not going to be getting it into the game at the moment. I'm just going to be texturing it. So once I do that, I'm going to move on to coding. All right, I think I've talked too much about sort of the code behind all of this, so I think I'm going to go on mute just to force myself to actually work and not narrate this stuff, because I think I could describe it for 4 hours instead of working for 4 hours. But hopefully that was educational at least. Yeah, now I'm just going to get to texturing. I'm not sure why. I've done this method before of combining them and then just painting them both, but for whatever reason, the UVs are not tracking over for the leaf, so I'll just work with them on separate objects. It's not that big of a deal. I think I'll talk for a brief moment kind of about what I'm trying to do here. I'm trying to get a Toon Shader in Blender working real quick. I have one in Unity, but I've never put in the time to make one in Blender simply because I'm lazy. Well, I've made a Toon Shader before, but not for this specific project. So I'm just making one real quick because it's not too hard to set up. I don't know why there's not a decent built-in one for Eevee. There's one for cycles, but it wasn't quite working there for some reason, and it's not quite that good. So I'm just making one real quick off of my memory of how to make one. Basically, I'm taking a standard diffuse shader and I'm filtering it through a color ramp with a very strict cutoff region. So essentially, instead of being instead of it being a regular diffuse, I'm taking the value and then separating that out. Now, the reason I'm only doing the value, 1 second. I have to write down when I start talking for sake of timestamps. Okay, so the reason I'm only doing the value is because we don't need to change the hue. So what we're going to do is we're going to plug this in here. Now we're going to get, hopefully, this with the Toon Shader. And yeah, it's not that good yet because essentially, I say essentially way too much. Basically, what I want to do here is make this a different color. But I'm thinking what I can actually do, I want to try something different. What I want to try is, I want to try doing a step, because I know the tutorials I've watched have always done a color ramp, but I've never quite liked it because it's hard to customize outside of the shader graph. So what I want to do is I want to snap. I want to snap this value, plug it back in there. Okay, so it's kind of getting what I want. I think I'm going to increment this. Believe more go. 0.2. Okay, and then before I do that, I want to do a mix RGB to change what the shadow color is. So let's go here. Let's separate this out. Okay, so now I'm making it so that it's not as black. So we can see it's mixing. Essentially, I need to have like a swear jar, except it's just the word essentially. What I'm doing here is I'm mixing the regular value, which would be black for the shadows and white for not shadows, and I'm mixing that with a different color. Now, right now I'm mixing it with white, and that's allowing us to decide how intense the shadow would be, but that's not exactly what I want. What I want to do is have this be the factor instead. And if we go between black and white, we'll get the same effect here. But what I want to do is I want to take the color of our mask and then do a hue saturation, plug this into the color, and then plug this in to our shadow color. But what I'm going to do is I'm going to take this. I'm just going to show this out real quick to show what's happening. What I want to do is I want to have the highlights be a brighter color and then the shadows to be a darker color, but not just so plainly black and white. So what we're going to do is take the hue and we're going to make that more blue. Actually, we should do it this way. I think what we'll want is, I don't think I added that in. Okay. I think with any color, changing the hue will pull it towards blue, but let's see if that's wrong. So 0.3, that's yellow, which is not closer to blue. Now it's pulling closer to blue. But it's relative to what the color is. We don't want that. We want to do that it's always becoming more blue. So, I mean, we could just mix it with blue. I guess keep it simple, mix it with blue. But I'm trying to think of the... There's a specific, it's not bright contrast, it's not... Let's see. Oh, well, what we can do for now is just simply mix it with blue. So we can do like blue like this, a dark blue for our shadows, mix that with this. Let's go ahead and out that. So we don't want it to be too intense, just a little bit. Okay, so now it's kind of making the colors more homogeneous, like the same, closer to all being sort of the same shade because they're being mixed with one color, and then also more blue, which is accurate to how shadows work. Because if the sun, at least in reality, if the sun is casting yellow light down, then it would make sense that everything it's not touching is less yellow, and anything that's less yellow is more blue. It's not that accurate. Like, that's not a precisely accurate way of saying it, but it is. You can think of it that way, and I think that helps in terms of art to think of it that way. And then we want to decrease the value. This is going to be a shadow, so we want it to be very dark, like 0.1. And then we want to saturate it a bit more, not too much. We could also change how much we want that to be intense, but we've got this blue, and we can crank up the factor a bit more to make it a bit blue. I think the more intense version of it is a bit better. Okay, so now that looks as if it's shadowed. I mean, it looks as if there's just no sun in the scene. So that's the color we want. So we're going to plug this into our black. And now if we were to put this out, we should get a more blue shadow instead. And it's still looking black. That might be because the snap is actually changing the color. Let's see if we plug this in, will it be? Because I think snap is actually making it black and white. It looks as if it's just gray. Let's see. If we were to crank this. Oh, yeah, because I'm plugging it into value. Duh. Okay. So maybe it's not the snap. And let's see if we put the snap out. What does that look like? No, so snap does make it black and white. So what we want to do is take the value, put the value through a snap. And we're going to take this up here. We can delete both of these connections. Take that out of the increment. We want to just snap the value. That's all we want to snap. Okay. So what we want is, let's see. We want shader. Okay. We want, we want this snap going into our factor because that'll dictate the shadow between this and our bright color. So this should show shadow and white. Okay. Now let's get something more like that. I'm liking that. Okay. Now what we want to do is, actually, we don't need this. We can just separate the value. Actually, we don't even need to separate the value because what we can do is just have this be white. Because we only need the lighting data from it anyways, so plug this in with a white value, don't need to separate, plug that into snap. So now we're snapping this, plugging this into the factor, and now let's take our highlight, which we could do a brighter color, but I'm just going to do what the color is. Okay, now we're faking, essentially making a false shadow. And now I don't like the lighting still. I think we need to change the step on it. Actually, I want it to be like 0.5, but what we can do here is add a remapping node, not a UV map. I believe, yeah, mapping. Nope. What is it called? I know it's remap in Unity, but I can't remember what it's called here. I think it's map range. Yeah, okay. We want to take this in as our value, plug this into that value. This is going to let us change. Yeah, we want it to be closer to. So that'll close it in. What we want to do is bring the max. Nope. I want to bring the max up. I want this to. Okay, that's a bit better. I think if we make this, it's hard to get it without just making it, getting rid of the black. Okay. Okay, there we go. We've kind of got a Toon Shader. Now what we could do is mix again and isolate the white to get highlights, because essentially the problem here is that there's no highlights going on. My dog is having a nightmare. If you hear that in the background. Okay, I think that's as much as I'm going to play with it for now. I'm not quite getting the leaves to look as I want to, but I think I'm just going to have to research how to do a bit better for leaves. Thought I could do procedural stuff and have it looking good, but then I realized as I was going through this, I don't even know how I'd transfer it to Unity, because I could convert it to a mesh, but then that mesh is going to be very high poly count, so it'd be better to have a procedural system in Unity. That way it can do GPU instancing, which will be more performative than having it be a mesh, because effectively they should only be particles, they shouldn't be objects. So I think I'll have to figure out how to do a procedural system inside of Unity to get nice looking leaves. That, or find a way to have a more minimalist approach to the trees, where I can minimize the amount of polygons in the actual leaves themselves, because right now there's just too high of a poly count to get something that looks good. Is this a little bit better, but still just a lot? It's a lot. I think that's like okay, but it'd still be well, let's see, 2500, that's 250, no, 2500, right? Yeah. 2500 just on the count alone, and it's 2500 times the amount of faces just in here, which is 16 faces. So 16 times 250. So 8,000 faces, which is quite a lot. That is looking better. But again, I don't know how I'm going to transfer that into Unity besides just baking it as a mesh. I think at that point it's just not even enough. Okay, but I think that's a good stopping point. I think it looks decent for now. And then I can tweak it later. But I kind of like generally how that's looking. I just need to find an approach that works better for the sake of performance. I don't know. And also, it's like, it's so stretched as well, which I don't know why that's happening. I mean, kind of know why. It's because the UVs are too spread out, they're too vertical. But that's something I can come back to. Okay. I'm gonna stop working on that. I'm gonna move on to coding now. Before I begin this as an event, I need to fix the way the code works a bit. I need to make the functionality for the rotation first, and then I can put it into an event. Because the way it works is that the call goes, gets technical constraints, then we go to the handle, then we go to the fire, and then that's where the functionality happens. So everything inside of the functionality is where we have the customized stuff, and then the part of it being an event is the fact that it has that call handle fire filter. So I'll make those filters after I have the functionality working. And I've nearly got the functionality working. I mean, you can see he rotates. The problem right now, though, is that the approach I had before is that the duration dictated the speed, which obviously is not what I want. But I figured out while working on the movement code how to find an estimated duration for a rotation based on a parameter of the speed of doing it. So what we want to do instead is do that same mentality of figure out how to estimate the distance we need to go. Now that's going to be difficult for when we're looking towards a target. I guess no, it won't be. It won't be difficult because I think what we need to do, because I don't even have this set up for movement. I have the parameters to move to a target, but it doesn't actually work. I mean, it works in the sense that it gets their position at the initial start, but it doesn't track, which is the whole point of putting a target as the parameter. But what I could do is have a separate timer, which is grab target position. And that can be filtered by the fixed buffer for how much that AI should be updating stuff. Then on that fixed buffer, so let's say the calculations for rotation or movement are happening every single frame. I mean, let's just say that, like that is how it works. Happens every frame. Because movement needs to happen every frame or else it'll look jarring and you'll see it jittering. But what we can do is, based on our fixed buffer, so let's say every 10 frames, we're updating our target. Now, when we update our target, we can say, what is the new arc of our adjusted angle to get to that target? That's going to be difficult with the movement because we have that sort of segmented distance. And so what we would do is only update after we've hit our tangent point. So you can think of it as we move to our tangent point and we don't change the calculation for that. We're not updating anything because it would be way too complex to update that based on where the target is, and it's ultimately not necessary. What we can do is move to that same tangent point no matter what. But then once we hit the tangent point and we start moving to the target, that's when we can start updating the target, update our arc. Essentially, we update the target, which will then update our arc, and then we can get the estimated speed, the estimated time based on our new destination to get there. That shouldn't be too complex of a calculation to happen every 10 frames or so. Maybe it would be if we had a lot happening, like say like 20 AI active at the same time. Well, really, any object that's moving on an arc is not just AI, but considering this is a boss game, we should be able to get away with those sort of calculations, since you're not fighting like 20 enemies at once. Okay, so that's the solution to that. Right now, I'm going to work on fixing this so that our speed is not dictated by our duration. Just a brief explanation of what I'm doing here. I'm trying to use the calculations that I made for the movement to get an estimation of the time of moving along an arc. The difficulty here is that I'm using quaternions for the rotation because rotations are handled with quaternions, which are four-dimensional units, where instead of you have in three-dimensional you have x, y, z. In four-dimensional you have I believe, I want to say I, J, K, W, but I feel like that's wrong. Regardless, they're not x, y, z. They're not equivalent. Like the quaternion is not a vector 3 with a fourth value attached. It's a completely different sort of data structure. It's a representation of a rotation, whereas a vector is more of a position. It gets more complicated when you use a vector as a directional thing, because when you use a vector as a direction, you're implicitly saying that the origin is vector 3, 0, which would be 0, 0, 0. So when you have a direction vector, like let's say your forward direction, which would be 1, 0, 0, you're implying that 1, 0, 0, the direction is from the origin, 0, 0, 0. You can't do that with actual rotations, like how an object is rotated, because, well, now, like, where's your origin? It's obviously not 0, 0, 0 because this object's all the way over here. It's not going to constantly like reference what's the position to figure out the rotation. So what it does is it uses a different value called a quaternion to represent rotation. Now, what I'm trying to do is to use the rotation I'm specifying in my data to draw a tangent line and then get an arc from that tangent. Get the arc of that tangent to get the time it'll take us to rotate to our target. The reason that will work is because a quaternion multiplied by a quaternion, which is what I'm doing here for the rotation. Our rotation is initial, our current rotation, to our target, which is our initial times getting an angle, getting a rotation angle from our current rotation to rotate 45 degrees. So essentially, what we're doing here is we're rotating 45 degrees, but in quaternion maths, which doesn't equate to vector math. But since I know what our rotation angle is, it's 45 degrees, I know we're going to be rotating 45 degrees. So if I were to draw an arc in 45 degrees, that's quantitatively the same as rotating that quaternion 45 degrees if we're using a unit vector. If I were to plug in this tangent and not have it be normalized, we wouldn't get the right answer because we would be measuring along an arc. I guess this is a good time to whip out Photoshop. Let's think of it like this. Let's get rid of these. Keep that. Get rid of this. Okay. So let's look at it as a quaternion. We're facing this way. And let's say that's forward. Well, our quaternion then is going to be 0. But for the sake of visualization, you can think of it as a identity, which means a quaternion of 0, 0, 0 would be here, and we want to rotate 45 degrees. Let's say 90 just for this drawing. We want to rotate 90 to face this way. Well, since the quaternion always happens from our source, and the distance is always the same because we're rotating from an origin, that is our position. So there's no factor that'll change how quickly you go from this to this in a quaternion rotation. It'll always be the same. Obviously, you can input speed into that, but what I mean is there's no scenario where rotation of 30 degrees for a quaternion is a different amount of time for another quaternion at a completely different location, rotating 30 degrees in a completely different orientation. It'll be the same amount of time, assuming you're not including some sort of speed element. So what we can do then is use a unit vector where it's normalized. So if we were to think of this distance from here to here as 1, then if we were to calculate out the length of this arc here, let's go here. If we were to calculate out the length of this arc, we would get the time it takes to move from this point to this point. If it wasn't normalized, then we might have a circle that's like this big, and then we're measuring an arc from here to here, and like, yes, it's still 90 degrees, but now it's all the way out here. So this length is obviously going to be way longer than this length. But when we use a unit vector where it's 1, we can estimate, well, not estimate, we can accurately calculate what the time will be for that quaternion rotation. Now, you can actually think of a speed multiplier as increasing the circle size, because what we do when we're introducing the speed element is we are increasing the amount of time it takes to calculate this arc. Now, math isn't magical. There's consequences to increasing the time it takes to cross an arc. You can't just increase the time it takes to cross an arc without increasing the size of that arc. And the way to increase the size of that arc is to increase the radius. Now, actually what we could do is just, what's more realistically happening is that we're just moving across this arc slower. But for the sake of visualizing it, you can think of increasing the speed of rotation is essentially, I think this is the actual applicable use of essentially, is increasing the size of the circle, because now we're still rotating 90 degrees. So we end up in the direction we want it to be facing. But instead of rotating at a unit vector where it's going to take this amount of time to get across, we can say that would be 1 second. Now we're going across all of this. And so it's going to be a bigger number. So that's what you kind of think of applying a speed. You're increasing the radius of that. But for this, we're going to be calculating the length of the arc. And the reason you couldn't just do this to this is because that's not how the quaternion rotates. It rotates on an arc. We can't just get the linear position. At least I'm fairly certain that's true. We'll find out when we actually apply this, because if my time estimations are wrong, then we won't rotate 90 degrees. Like, let's say I'm wrong and it's not an arc, but it actually is a direct translation. That'd be really weird, but it is possible that I'm understanding quaternions wrong, and that quaternions actually work like this, where it goes straight line instead of an arc. We'll know because my time estimation will be off, and if my time estimation is off, then we won't go the full 90 degrees. We would go like 70 degrees. So we're going to test rotating 90 degrees, and our goal is to get a time estimation of that by using the current utilities I've already made with vector math. Once I do that, I want to create a version of this method. Well, a version of this method that accepts quaternions. If I can. If it's too complicated to do that, I won't. But it would be nice if I could just throw two quaternions in there and get a result. Oh, and then briefly describing this. What I'm doing here is I'm saying, what is our forward direction right now? And then what's our axis of rotation? So this can be adjusted depending on how we want to rotate. Like, we may not want to rotate normally. If we go into the project, we might not want to rotate like this. We might want to rotate like this. You can think of, like, for projectile, that might be true. And so that's why we're doing this. This is going to get us a tangent direction based on our forward and the axis of rotation that we want to go on. I think that should be the correct approach. And then we're plugging in that rotation. That'll get us our tangent, and we can use that tangent to get this by doing vector 3.0 and then this tangent, because this is going to be normalized. The tangent returns a normalized direction. My problem here is that I'm using vector 3.0 when this really should be the same as this. It should be our forward. And now that should work. Okay, what I'm testing here, it looks like it's working. I'm going to be testing whether or not it's actually taking 1 second. So we can set this to 5 real quick, our game time. And that should stay 5, it shouldn't snap back. We're going to test fire while we're paused, and I set up a debug break so that the moment it finishes rotating, it'll pause. So let's see. And it's a little bit more, but as we saw with the movement, for whatever reason, it doesn't accurately go to the time input. But as I said with the movement, if everything's off by 0.3 seconds, then nothing's off by 0.3 seconds. So should be all right. Okay, now let's see what we do 180. We go the opposite direction, but we shouldn't even be going in the opposite direction there. So I think it's not really an issue we can fix, but I can't see a practical case where it would actually matter that something's rotating the opposite direction one way or the other. Like let's say the player's over here, it doesn't matter if we're rotating all the way around this way or the other way. So a short will be less data than a float. Now, for almost all the majority of your coding, it doesn't really matter that you're using the right data structure. Like the size of variables is such a small part of your performance problems. Like in terms of what is the bottleneck of your performance on your game and how could you fix that? Or not even a bottleneck necessarily. Like what are the optimizations we could make to make our game perform better? Like the variables would be the bottom of that list almost certainly. In terms of like integer values, like in terms of using a double or a long or using a byte or a short or an integer, like if you use integer and floats for everything, in terms of performance, you're going to be fine. Like if you're in terms of accuracy, you shouldn't be using floats if you need something super accurate. Like a float's not going to be accurate enough. But in terms of just pure performance, like if you use ints and floats for every value, like numerical value you need, it's not really that big of a deal. The reason though that I need to be doing it for this situation is that these are going to be stored in an event system. So each one of these values is going to be taking up space, and there's going to be a lot of these, like a lot of this data. That doesn't matter when it gets saved to JSON, but when it gets pulled out of JSON, which takes time, we don't want a whole bunch of data sets. Now, that doesn't matter as much because I have an optimization there where we batch pull from our replay system. So for example, if there's 10,000 events, I know for a fact those aren't instantaneous events unless something's terribly wrong with the game. They're going to be spaced out through time. So what we can do is batch pull based on an incremental time. So pull from 0 to 1. Okay, there's 200 events in this. We pull 200. We wait until all of those events fire, pull the next 200. So we have that sort of batching going on. But it's still the case where we're pulling so much data, we want it to be as small as possible. And so I try to use the smallest value I can. This is really the only scenario with this event system where I actually care about using the smallest data size possible. Because if you don't know too much about coding, everything takes up space. There's nothing that doesn't have a cost. Every single thing has a cost. With modern technology, it's hard to notice that cost because it's so easy to calculate. That's why it's just a general trend that as hardware gets better, software gets worse in terms of optimization. Like if you look back at what the initial optimizations had to be made for video games when they were first, like when they first hit 3D, it is insane what people do to optimize. And AAA games today, the good ones anyways, not the bad ones, are still doing those sort of optimizations. You can see that not being true with games like Call of Duty that have a 200 gigabyte download size. Obviously, they're missing some optimizations there. There are reasons why it's bigger than it used to be, but there are reasons why it could be smaller. There's really no reason it should be that large. There's optimizations they could be doing. And those sort of little optimizations are everywhere. And the more you don't have to rely on strict hardware, the easier it is to get away with not paying attention to minute stuff like this. Like I don't need to care really about the data size of a number because of the fact that hardware is so incredibly advanced just from 1 decade ago. Because it's down to bytes. Like the difference between an integer and a short is about, I want to say 16 bytes, which is very, very small. Very, very, very small. And I mean, obviously that doesn't just come down to hard drive storage. I mean, this literally isn't hard drive storage. It's RAM and GPU usage and CPU. But yeah, sorry, that's a long tirade about about how much it doesn't matter that I'm using this, but I want to make it a short instead of a float, since we don't need that much accuracy. Well, when it actually gets calculated in these complex calculations like the tangent angle and stuff like this, it's treated as a float, which is fine. It's fine to treat it as a float. What I don't want is it to be saved as a float. I want it to be saved as the smallest possible data size, and a short is the most we can get away with. Okay, I think I'll go back on mute and then just keep working on this. I feel like there was something else I wanted to talk about with that, but I ended up talking about data structures far longer. But I'm sure I'll put my mic back on when I think of something else. Okay, sorry I was AFK for a bit there. My dog's having stomach problems, so had to help him with that. But now what I'm doing, I want to go over what I'm doing just a bit. I realized what I could do is calculate the angle between the initial quaternion and the target quaternion. And if I could do that, then I could plug in that rotation into our get tangent direction instead. And if I'm able to do that, I can create a more, I could create a function on the utility math script where I have get tangent direction, but I have a variation of that where we can input two quaternions as an initial and a target. We could then, within that method, get the rotation angle and get the tangent that way. The reason I would want to do that is because it won't always be the case that we have a rotation angle of two quaternions. Maybe we want to figure out the time between those two, but we don't have a quaternion. Sorry, we don't have an angle. We just have two quaternions. We want to figure out what's the tangent direction for those. Actually, I'm thinking even this should be nested into get to time target where we have two quaternions instead, shouldn't it? Because at the moment, that's really the only reason we need a tangent direction. I suppose we could do both, but what we can do here is we can obfuscate that get tangent direction into a get time target spherical call, where instead of inputting a origin and target for a vector, we input a quaternion. Now I'm thinking it doesn't make sense actually to use spherical because, well, no. We have to use spherical because it is an arc we're going across. I was thinking because we're not slurping the quaternion, but we are calculating an arc. So yeah, we need to use spherical. But what we can do is instead of inputting two vectors that we get from the tangent, we can put that stuff inside and just input the two quaternions. That way, every time we have to do something similar to this, we don't have all of this extra stuff here. We can just plug in, well, all of this extra stuff, these few lines, which it's not much, but when you consider that there could be a bunch of other cases where I do this, it would be nice if it was one method call where I know I'm not going to mess it up. Especially, oh, wait a minute. You know, I think it actually doesn't matter, right? It shouldn't matter what axis of rotation it is, because we're always rotating some amount of degrees. And whether that's, yeah, it doesn't matter. Because if we're always rotating a certain amount of degrees, there's never going to be a situation where those two axes force. Yeah, we could just assume forward and upwards because this is only for the purposes of calculating the time to cross an arc. So it doesn't matter what orientation that arc is. It's going to have the same time no matter what, because we have a specific angle we're going across. So yeah, well, not vector dot 0. We want vector dot up, and then this could even be vector dot up. or vector.forward. As long as it's two vectors that are perpendicular to each other, we should get an accurate calculation. It shouldn't matter. Yeah, okay. I'm just gonna hope that's true and move forward. So yeah, that's what I'm gonna do right now. Make this a function where we can just plug in two quaternions and we get an answer to simplify things. Yeah. Funnily enough, I was talking earlier about the fact that I would need to estimate the calculation of a moving target. And I was saying I could use this sort of iterative thing where it only happens based on the fixed buffer time, and it's not frame by frame like the rotation is or the movement is. And I said I could use some sort of step thing where we're checking every 10 frames the rotation, and it turns out I literally already coded this for the rotation. So glad I already figured that out. So the issue with this is that every time we calculate a new rotation target, like the new issue with this is that the time is going to be different. But what we can do is when we calculate this rotation, we can out a max time. So we could out, we could out max time. And then if that's more than what we currently, well, not even if it's more. The problem I'm thinking of right now is that we have duration, which is only go to this time and then stop. But then we also have the time it takes to get to the target. And if duration is ever less than the time to the target, then we need to stop at duration. And in the previous method here, I combined that into one value, the max. But I'm thinking we ought to, actually, no, I shouldn't be doing this at all, because right now what we're doing is we're saying we're going to get there. Like if we put a duration of 1 second, well, we're going to get there in 1 second now instead of 4 seconds. So this is actually going to be changing the speed. So we shouldn't be doing this regardless anyways. What we should do is go back to having this equal rotation data dot duration. We can have that, but then we want to also have and t is less than t to target. Similar to what we were doing for movement. We don't want to do this. We can just get rid of that. So now we have our maximum time, which is our duration, and our time to the target. And now we will enter either, and then we need to replace this with t to targets. Now, rotation here, we're already doing that thing I was talking about, but we need to add another value of t to target. And we're going to have to recalculate this each time. Let's go ahead and do that right now. I'm going to stop talking about it, but basically I'm going to be working to get a new time estimation based off our calculated rotation for our new target. That's the goal here. Yeah, I just forget things. I completely forgot this code even existed, but I remember testing it now. Now I remember testing it. And I thought it was cool how the line pointed to the target and you could see it updating, and I was like flinging a plant around. The Mole King was tracking it, but I completely forgot about that. So yeah, that's part of the reason why I make sure my code is so well commented, because I just can't remember it all. There's so much code. Like a week will go by and I've forgotten what code I have. So the more I can obfuscate it and make sure it's well documented and make sure it's doing exactly what it should and that it can handle any sort of case scenario, then I'm less likely to mess up my code in the future. But there are situations like this where I just completely forget that I already did something, and I end up nearly solving the same problem twice. But that's the sort of thing I try to avoid. And luckily, I avoided that by sheer luck this time. Okay, cool. So I'm pretty satisfied with how this turned out with the rotations. I want to test real quick look target as well. So what we can do here is we're going to start. This is the sort of thing I have to hard code because it's not in the replay system yet. But when it's working, well, it doesn't even have to do it's not in the replay. It's that it's not a call yet. So like making it in the call just has the added benefit of putting it in the replay system, but making it a call allows me to target something, grab a target of something. So we'll throw that. I just have to hard code it for testing. And so we will throw that target in. We'll change this from angle to look. And then we will crank this to 12. And then we should look towards our target, but we are not. Oh, that error is only because it throws that error because this shouldn't be happening during runtime, but happening in editor is fine. Okay. But then that doesn't explain why we're not rotating. So the code must be messed up. That's what must be going on then. Because yeah, that's fine. Okay. We're getting the look target. It's getting speed infinity. Okay, well that's an issue. I think I must be plugging in the wrong value. Oh, I'm plugging step time for speed. That may not be the issue, but it certainly is a issue. Oh. I was thinking why would step time be infinity? And I realized it's because we're using max time over max steps, which isn't going to work here because we have that set to infinity. So let's see. So what we should do is no longer calculate it here. Instead, what we should do is after this, do step time. It's going to be time to targets divided by max steps times max buffer. Okay, that's why we're getting infinity, and it was plugging it in there, and so that was getting us speed of 0. Okay, well, speed of infinity, which would get us a time of 0. So now, let me set this up correctly. Look, then we're gonna have to grab during runtime that newly generated ID. Okay, we can plug it in here, and now going slowly. Okay, it snaps. Okay, why does it snap in the middle? I'm gonna assume it's because of this. Let's see what happens if we stop that. And also let's do lerp here. I don't know why I have it as slurp. We could actually keep this the same by having it play. Okay, I should have followed general science practice and only change one thing at a time. Let's go back to slurp for that. And then we'll have this so that now it gets a new ID. Wait. Oh, I did that while I was runtime. Okay. So let's play again. Now this ID should change. Okay. Look. Okay, we can keep that as slurp. I think it's literally the same. Well, no, might as well do lerp. I'm sure it's an easier calculation, and since it doesn't matter, should be lerp. Okay. So the issue is this here. I think the problem is that we are using the current position. We should be using our starting position, because our time to target is based on our entire length, not. We might think I might want to pull this out just because there's too much information we have to pass in just for this. Because basically we need to use the initial position instead. Well, no, initial rotation, right? That's what we want, initial rotation. But let's see if it should even be using. This needs to be current position. Cool, we can see it updating as well. So let's try moving the target and see if it keeps updating that time. No, it doesn't quite work. Now, is it not working because we're changing the time to target, or is it not working because of the calculation? So let's try throwing out a dummy real quick. So that way time to target stays the same. And let's see if it's the new rotation that's causing the issue, or if it is the new time causing the issue. Okay, I needed to take a moment to really think about what was going on there, and I realized the problem was that we were calculating a new time to get from a quaternion to a new one. We were changing our target, and I wasn't updating what our current rotation is going into that calculation. And then when we came out of it, we were still moving from that same initial position, which caused us to jump forward because, we were taking into account our current rotation when finding that target, but then we were using the initial rotation to get the time and the initial rotation to continue moving from. The problem is effectively what we're doing is resetting this while loop. So what we should be doing is changing that start point, because we're getting a new target. We're effectively restarting the loop because now we have a new time estimation of when we're going to reach it. And when we do that, we're using the current rotation to dictate where that movement is. And I think that's a better way to do it. Because I could, in theory, use the initial rotation still, and then have that factor into the time we estimate to subtract the current time we have so far. But then there could be instances where it's not quite accurate, so you get this little tiny snap of a degree or two. But if we do this, we're resetting the loop in a sense. And we won't stop until we reach the target, because the step time, if t is greater than step time, what we should do as well is I was thinking we might want to do something and step time is greater than target, but then we would never end the loop, because that would cause the loop to go on forever. So this is the way we have to do it. If there's a time less than the step time, no, that's literally impossible for a time to be less than step time, because we're using it's literally impossible for the step time to be less than our target time, because our target time is used to dictate what the step time is. It's a ratio of that. So yeah. This should be in parentheses. Okay. Because we want it to be max time divided by steps. Well, step time divided by. No, I think it's okay to have, because we want it to be time, which will be, let's say 10 seconds, divided by max steps 10. So we're doing a step 1 every 10 seconds. Or if we were doing decimals, if it's 1 second for the full duration, 0.1 seconds every step. Then if we multiply that by our buffer, we get a higher number. So that's where we could have issues. Because let's say our fixed buffer is so large that but I guess that's a problem with performance, right? Because if we have a buffer so large that the calculation doesn't have time, then it's a sign that that buffer is too large. But we should have a check anyways. We should say if equals, so then we'll have conditional. If step time is greater than time to target, then we're just going to say step time equals time to target divided by 2, else just equals step time. Okay. It's fine if it's less than the duration because that's like a stopping point for the rotation, so it shouldn't continue anyways. What we should do is because let's say we have a max time of 5, then we should keep accounting for that because we only want to go for 5 seconds, so we need to subtract the current time if we're going to be resetting it to 0. Yeah, okay. What's the issue here? Oh, yeah. Okay. Okay, now this should work. I think we'll still have a problem with big rotations. Let's see. Nope. Cool. Cool. So he's too slow, but it works. It works. Oh shit, it's falling. Now I want to have some fun and do it with the player. So this is going to be a bit difficult to set up, but I think we can do it. Well, I have to turn replay off. Okay, so what we're going to do is we're going to grab the ID of the player, give it to the mole king, throw it there, rotate at the slowest speed possible, and we're going to run circles around it. Okay. Okay, go. Oh, shoot. Okay, he caught me, but we'll do it again. Let's cheat a little bit. Let's maximize as well. Well, maximize on play. Okay. That's AI, that's it. This is all the AI the game has. That's all we need. He just can't keep up. He just can't. He's just no match. He's no match. This is what happens when developers play their games. They're just too good at them. They're just too good. This is why Miyazaki doesn't play Dark Souls. They're just too easy. when you're messing with the master. Okay. Cool, we got that working. Now, before I forget how that works, I think we ought to do the same thing with movement, because at the moment, I also need to pull this off of there. Let's pull that off. That's wasted data. Pivot, there we go. Let's go to move data. Now, move target ID. I believe what we need to do is just change the movement script. Okay, what we're going to need to do is change the movement script to add that step. So that's what I'm going to be doing. I'm going to be pulling the sort of functionality here. Now, I don't think this is something I can make into one method. I've tried to do that before, but I just don't know how you can pull a coroutine out into a generalized method. That's my one boon that I have yet to figure out how to do. But that's what I'm going to be working on now that I figured out rotations. Rotation, I wanted to just be getting into an event. I still need to do that, but I needed to fix the code first. And so now the functionality, well, I guess I stated that I'd be doing that first, fixing the functionality, but I fixed the functionality of the rotation. Now I'm going to make sure the movement has that same thing, because currently you can't move to a target, like update that movement, which is what we need to add now. That's what I'm going to be doing. Okay, I think I'm going to end things there. I don't really know what's happening here, to be honest. I've gotten it to a point where I like how it goes, but it's not exactly good. So I don't know. Because if I turn this back to a nav agent, I don't think it'll work. Let's see. I've been basically just trying to get it to recalculate that movement as it goes, but no, the nav agent just gets stuck for whatever reason. I think it has to do with the calculations, but that shouldn't be a problem. I'm gonna see if it has to do with these. See if it's see exactly what the issue is. So now he can move through those, and let's see how it goes. Because it doesn't really make sense that the nav agent, why is the nav agent getting caught up there? What if I move it? It's still stuck. So why is it that when it reaches the midpoint, it can't move as a transform? Let's try it as a player. Okay, as a player, it's fine. My guess is that it's because the direction isn't strictly on the XZ plane, it's going Y as well. But that doesn't make sense why it would just mess it up forever. That's what I don't get. I think that's all I'm going to do for today, though. I went a lot longer than I expected to, and now it's like nearly 1 a.m. Yeah, I got 2 of my goals. No, I got 1 of my goals done. I worked on rotation and fixed a lot of that. Started working on the movement because I needed to fix that before I started doing the rotation event. I wish I had just gone into the rotation event because I didn't realize this would be such a challenge. I think I'm just going to have to drop it for now and disable it for now, because it's just completely flawed from the way it begins and everything it does. It's just completely flawed. So I need to rework that. It's not good as it is now, but got everything else set up. Let's see. Now he should just stop there. Yeah, okay. Honestly, maybe it's the case that I shouldn't even have that. No, because I can't just keep wiping movement, because then if the target's getting pushed, then he wipes his own push. I'm not sure. But I think I need to ignore it for now and just get the rotation set up so I can have that done, because this movement thing where you can track a target isn't necessary right now, because I'm going to work on AI next month and I need to work on just player stuff right now. So this issue isn't part of that, and waiting on it won't snowball any issues. So I just need to leave it for now and then work on rotation events, then work on player code, which hopefully I can start on tomorrow, but we will see. I think I'll end things there. I don't think I talked too much the last while, but yeah, I don't have too much to add. I got some good work done, but most of it felt incomplete for what I was doing. Like, I didn't finish texturing the tree, I didn't finish the leaves for it, I didn't finish this movement thing. So a lot of no progress. Today's stream I'm going to be working on player movement controls and then rotation. For the player movement, I will most likely just be doing a more chaotic approach to getting the code done, just to have something that I feel works well in terms of getting the functionality I'm looking for. And then from that, I will double back and rewrite the code to be more organized. But my first pass is always a chaotic and rough one. So I'll be doing that. Before that, I'm going to be setting up the rotation into an event. It should be fairly straightforward because I have a sort of pipeline for making any sort of action into an event. So it shouldn't be too difficult. And those are the two things I'm working on for today. I will have timestamps if you're watching this in the future for when I talk, but for the majority of the stream, I will be having my mic off, which I'll probably start now. I don't think I have too much to comment on to begin with. Last stream, I was working on the movement because I was trying to get it to update a target position if we had a tracking target instead of just a static position to go towards. I wanted to be able to track, but I couldn't quite get it to work with the arc movements. But I'm just going to drop that for now and work on getting the rotations into an event, because basically our entire replay system works except for rotation. That's the only thing not being tracked right now. So I need to add that in, and then I can work on player controls and getting that set up. I just want to show real quick how quickly I was able to set that up. Like, it was pretty mindless, me setting that up. Because basically I'm just converting this into an event so that any sort of object can call this action of rotation instead of it being a method that's specifically on the rotation script. It's on the controller and it has checks that will go along anytime rotation is called. So let's actually turn off the replay, wipe that. And I want to show the replay isn't going to be set up with this yet because we still have to do that part, but I want to show how easily I was able to turn this into and part of the event system. Like, that didn't take long at all, and I wasn't even thinking. I was just copying what I knew I needed to copy and then filling in the blanks. Except I didn't add, I forgot one thing, which is adding it to the call. So, well, the testing. So, like, it's actually an event, but I don't have the actual test set up. And to add that to the test loop. and now it should be good. Because this is just like code for testing stuff out. I guess self-explanatory there, but it's not code that's going to stick around. So now, I guess, hold on, I'll set it up before so it doesn't get wiped. And so now it's working as an event, meaning we can call this on any object, and it'll still work. I mean, that was already true, but now it's actually an event where it has the proper checks in place so that another object could call this onto another object. That's not obvious in testing, but it's a big, big, important part of making these events work as they should. Now, the next thing to do is make it part of the replay system, which will be just as easy as that because of the sort of pipeline I have set up, where I can just copy and paste stuff, fill in the blanks for rotation, and it's pretty simple. That's what I'll do next. So if it's not obvious what I'm doing here, basically, when I originally set up this system for all of these events, I put checks in place to throw errors when something was going wrong. So these errors I'm catching, I'm purposely starting up the thing to see what error pops up, because I know I set this up for myself to catch every problem. So essentially, I don't remember how I'm supposed to add a new event. I don't remember at all. But I know that I made it streamlined for myself when I set it up so that I wouldn't need to remember how it works, because I would have these errors that tell me exactly what's going wrong. So I know that basically I have it set up that it throws an error when we've added a new event and there's some method that isn't tracking it. So you can see right here, failed to find case for type rotation. So that's pretty clearly, okay, I need to fix something here. I know I'm adding a new case. I know every one of these cases is basically identical except for the type of data. So all I have to do is copy what's already there, change it to rotation, and change all of these to rotation. And now they're in there. So then we can test it again, see if it works. Failed to find case for rotation event. So again, we're catching these errors. I have it set up, like this isn't built-in Unity stuff where it's catching these errors. Something like this is built-in Unity stuff catching an error, but this is stuff I set up to make sure when I came back and added a new event, whatever the event is, I would catch that. And it involves doing this more complex system of, like, the point of this is to handle every single event, and I easily could have done an if-else chain handling each case, but instead I made them into an enumerator with cases, because then I could have a default. Every time we don't find a case that is being passed through, then we throw an error, which you would not get if you were doing an if-else chain. I mean, you could, but it wouldn't be as easy to figure out what exactly you're missing. Whereas this, I can easily say what I'm missing. And it looks cleaner in a switch. And then I think, I can't even remember the other reason I didn't just... I know when I was designing the system, I was thinking about I need to have these in a switch with cases so that whenever I add something new, it's easily caught. And I recall the more simple approach, not having that sort of result. So the ease at which I'm able to just add this stuff in by just simply seeing what errors are thrown is specifically because I designed the system knowing that I'd forget how it works, which I think is very important to do when you're coding, is to make sure you design a system so that even though you don't remember it months down the line, you're able to learn it again, or at least understand what's going on simply because you documented it well, you set it up well, and it's very hard for you to completely forget it once you're so easily reminded by your past self. So I think that's very, very, very important. I think it's something that's not exactly taught. I mean, I'm not exactly educated, but I don't think it's something that's easily picked up on, the fact that you need to design code with the knowledge that you're going to forget it, especially when you have big projects. Like, unless you have a very, very good memory, it's unlikely that you're going to remember the functionality of tens of thousands of lines of code. And even if you can, if you're working with multiple people, then all of that goes out the window, because it doesn't matter if you can remember it if someone else looks at it and they don't know it, because then you have to waste time explaining it to them, or worse, they try to tinker with it, not understanding it, and it ends up breaking. I've never had to work with other people, but I have to work with my future self, so my future self may as well be another person in terms of understanding what I write at this moment, because I'll just completely forget. But with this, like, I'm literally talking while I do this stuff because it's just mindless to copy it, and I think now it's working. Yep, there's all the rotations. We can test that at a slower speed too, because why not? Maybe I regret testing it at a slower speed. Okay. On to the next one. There we go. Okay, I'm just gonna say it's working. I don't want to wait the whole like 5 minutes for all these events, but yeah, it's working. So we can do it at double speed too, and see them firing off. You can see all the data here as well for the rotation events. Okay, so that's the last thing we needed. Now we've got everything captured that we would need to have the game work in a replay system, like just to look to look nearly identical to what you played. So if you were to do the replay system, the only thing that would be different is rigid bodies, because of the way physics calculations work and the fact that they're essentially random each time, even if you have the same exact inputs. I could put systems in place to nullify that, but I don't really care to, because it'd be like an end of the road sort of thing. But yeah, I set up the rotations as an event, and that took me all of 30 minutes or less. So it took me 30 minutes or less to set up that as a history event that now is integrated into the replay system. So I went from just having a function that is isolated to this one method into a call that can be called from any script, literally any script, and then it goes through check filters. And then I put that into the history so that we could have it in the replay system, so you could replay the game and see it happen again. Which I'm happy it was that quick to do that, because it's not exactly a simple endeavor. Like, if you were tasked with doing that functionality without a base system, it would take you much more than 30 minutes. But because I created a system where it's incredibly streamlined for me to add that into the system, it only took me 30 minutes. Like, let's say I didn't have all of that coding. If I didn't have all that commenting, didn't have that organization, didn't have the easily streamlined setup, that could easily have taken me 2 hours to set that up, because I would just have to try and remember everything that needs to be done to set up that event, instead of just following breadcrumbs. So now I'll move on to player code, I think, and then just work on that, which is going to be much more chaotic than the simple, elegant, streamlined nature of what I just did. All right, so what I did there is I made the player's input of rotation into an actual event call. Before it was just directly rotating the player. You can see it's doing that here. And it's not actually what we want. Also, this should be... Yeah, so actually we're still doing it, which is weird because are we rotating it and it's still capturing it but not actually rotating it? Oh, because we're rotating it to where it's already rotated. I think that would be it. Basically we want to get rid of this. What I did is before we were directly moving the rotation, and that's not going to work for being part of our replay system and being part of our event system. So for example, let's say our character is currently stunned and they can't rotate. Well, this just says rotate, so it's going to rotate. But when we go through the call, we can have checks that say, okay, the player is stunned right now, do not rotate. And instead of having to change code here, it's just within that event system itself. So that's the purpose of adding it there. And then as well, we can do rotations. And so you can see now we're getting that rotation going. And imagine it was just doing double the amount. Let's turn it off and let's go to rotate. So it's just calling the event. Now we've uncommented that. You can see rotating. Now an issue with this is just how many events it causes. Because this is happening a frame per frame basis, you can see that it generated over 1,000 events. Let's see. Yeah, 1,200 events. Now this isn't going to cause any performance issues, but it is a data or a storage issue. Now this many events isn't that big, especially considering a large portion of my save system is a debug part of it. So if we look at our event history, a large chunk of the events is storing this string, which is like almost the longest part of any piece of data. And the reason it has to store that string is just because so I can debug it. That's the only reason. It's just for debugging. So when the game goes live, when the game goes live and I'm done with this, I won't have that. Or just when I feel like I'm done, I don't need it anymore for the event system, I'll get rid of it. But that will cut down a lot of the size. However, 1,000 events is problematic considering this is just a few seconds of time. But I have a theory for how I can fix that, and my thinking is that I can drop these events into parts that are split up based on time. So like every 5 seconds, well, maybe that's too long. Every second, we condense the player's events into one event. I don't know how that would go, but it's an optimization I could do, not one I have to do, because it doesn't really affect in-game performance. It's just a storage thing. And considering this game's going to be pretty small, I don't think it's that big of a problem if you have like a 10 megabyte save file. But yeah, so now we've got rotations working. Next thing we need to do, well, we have rotations working as part of the core system now instead of just being hacked together. We need to do the same thing for rotating the camera up, basically looking up and down, because that'll be rotating the hands rather than the legs, which we have as two separate active managers.